All right, good morning. Here we go. We have 3 more lectures left, and I'll be passing you off to Marie Henry. She will be doing the course from here. I think there's going to be a change in time slot, but I think she also just does the YouTube videos, so I don't think that's going to be a problem. And the quizzes will be up. They're coming up. I had to make a correction on the precision one, so that'll be just a redo of a quiz, so it shouldn't be a problem. There'll be a vector quiz coming up very shortly, and then there'll be one last one, solving for x, and the stuff that we're doing right now. And then we're going to have a test, and the test is not going to be this week, but it'll probably be next week. There'll be a good 48-hour time slot where you can log in to Blackboard and write the test. But all the stuff will be written in the email, and you can read it from there. So let's real quickly talk about what we did last week. Okay, so we've introduced addition and subtraction of terms. Okay, so we're always solving for x here. So we're subtracting terms away from one side to isolate our x, and that works by moving all the terms around. The second thing is we have coefficients. So we have the coefficient in front of the x term. Okay, so first thing we have to do is move all the terms first, then deal with the coefficient. And the coefficient, it's multiplied by x, so we have to divide it out. Same here. This one is divided. X is divided by a, so we have to multiply it by a to get it out. Okay. And then we're doing combinations where essentially we have to do subtraction of the terms first, isolate our x, and then remove the coefficient. Okay, so we've been doing stuff like that. So review of level 1, been moving terms around. Okay, so this is all stuff that we can talk about. You can look at the last video. So the rule was to move all the terms around with x first, then deal with the coefficient, right? So that's what I was saying. So you move all the terms first, get all your x's on the one side, all terms with x's on one side, all terms without x's on the other side, and then you deal with that coefficient. Okay? So this is what we were doing last week. Here we go, all stuff on YouTube. And now we're going to start dealing with the brackets. So now we're going to introduce brackets. So we can only remove brackets when you have an addition in front of it, nothing else in front. Okay, so plus bracket open, and then nothing else behind it. Okay, so no to the power of, nothing multiplied to the power of. Okay, so this one you can't get rid of it because it has a minus sign. This one you can't get rid of because it has something multiplied by the bracket, and this one you can't get rid of it because it has to the power bracket to the power of something. Okay, now these ones here, when you have this multiple, minus is just plus -1. Okay, so that's a real easy thing that we should always do. So if you have minus, it just means minus -1 there, and you just multiply that in there. And this one, the multiplication, we can deal with these two. Okay, and that's what we're going to deal with. This guy here, we're going to talk about this later, but we're not going to deal with him right now because first thing it's exponents, and we haven't dealt with exponents yet. So all we're doing is multiplication. And for multiplication, all you have to do is just multiply into the terms. So every single term inside the brackets gets multiplied by the outside, and that's how you expand brackets. Okay, so the new recipe is you have to expand all brackets so you can access the terms with the x, and then we're back on to what we did before, where you move all the terms with one side, you move all the terms with the other side, and then you have to consolidate your x's, but we'll talk about that, and then you deal with the coefficient. Okay, so here we go. So you have an x inside the bracket. You have to multiply this into there to get that x to get the x out. Okay, now you can move all the stuff over. So you isolate your x on one side, everything else on the other side, and then you can deal with your coefficient. Look at this thing. It's crazy. I have a fraction. You have to expand it. So you have to multiply this by the bottom here. Okay, it's not just a simple number. So you have to multiply by the bottom here. This will cancel the bottom, and you have to multiply. When you bracket open this thing, you have to multiply by both sides. So I think I did this 2 ways. Here it is. That's right. So you multiply this 2 ways. So you got to multiply this into 2 terms right there, and the second term also gets multiplied by that outside. Okay, expand everything, and then you can move your x's to one side, and everything else to the other side. I showed you this because I just wanted to show you how complicated it is to try to have a general rule for solving for brackets to the power of some constant. Okay, the general rule for solving the brackets to some constant is called the binomial theorem. Okay, and it's very complicated. We're not gonna do that. Okay, but what we have done is we've done to the power of 0, to the power of 1, to the power of 2, and a lot of you probably remember this power of 2 stuff called FOIL. Okay, so you'll see this later on, but we're not going to deal with that right now. But you guys never want to see this. I never want to see this. Exponents do not expand like multiplication. You're assuming that a level 3 is doing what level 2 does. Okay, level 3 is so much more complicated than a level 2 when you multiply. And then we had some extra problems. So let's just continue on with some brackets. So we're going to solve for x. We'll do one per page now. Okay, so here we have to expand the bracket first to get to our x. Okay, so we're going to expand the bracket first, bring that into our two terms. Okay, now we can access all of our x's. So now we bring all our x's on the one side and everything else on the other side. So I'm going to subtract x from this side to move this x, and then I also have to move this ab here, ab, subtract ab, and this has an x in it, so we're all good to go. So now this is going to be a nice one. So 4ax minus x equals 4 minus ab. Now, this is that second step there. Okay, so now we have, let me just get this a little cleaner here so I can go 4ax minus 2x equals 4 minus ab. Okay, so this was a kind of a new thing I want to show you here. And as soon as I've done this, as soon as I've shown you this, then you know how to do all brackets essentially, except for the to the power of, okay? So let me just see here. Where's that recipe? Yeah, there's that recipe. Okay, so expand, we did it. Expand so we can access all the terms with x. Terms with x, we isolate to one side. Did it. Without x on the other side. Did it. Consolidate x till you only have one coefficient. Okay, so what I call this is a reverse bracket operator. Okay, so what we want to do here is we have x's in two spots. So what we want to do is we want to take x out. So what we're going to do is we're going to do a reverse bracket operator here. Okay, we're going to take the x out. So this thing will become x times 4a minus 2 equals 4 minus ab. Okay, so if I multiply this x back into here, I will get that back. Okay, so it's remember, math works forward and backwards. It doesn't matter, right? It's a recipe. And now I have x with one coefficient, and that's the thing, right? So I consolidate x. So I only have one coefficient because it's hard to divide by these. How would you do that, right? So you have to divide. Now you can divide by 4a minus 2. Divide this by 4a minus 2, and we're good to go. So x equals 4a minus 2. No, shoot. X equals 4 minus ab all over 4a minus 2. Okay, so that was a hard one. But if you understand that, then we're good to go. You're good. You're all the way up to level 3. Let's do a couple more. So yes, this has a coefficient, so I could take out the x right away. X is already on the one side, and this is on the other side. So you could expand this, or you cannot. Okay, it takes a little more practice here to really understand that we take it out. But if we wanted to expand it first, we could expand it first, and we just get ax plus 2x minus bx equals 4 minus beta. And then now again we have all the x's on one side, and we have everything else on the other side. And now we're going to do a reverse bracket operator. We're going to take all the x's out. That's why you have to have all x's on one side. If you don't have the x's, if you have one x over here, it won't work. So I do a reverse bracket operator, and then I can divide by everything else. And there it is. Okay, let's start doing some harder ones here. Let's start doing some harder ones. Okay, so it might look like we're good, but we still, you gotta expand everything. You gotta isolate those x's. You gotta isolate all the terms, okay? Because you just can't take it out. You got this, I always get rid of that fraction right away. That's the first thing I do, is get rid of that freaking fraction. I'm gonna multiply everything. Remember, I have to multiply the whole thing. You can't pick and choose. Now it starts getting a little complicated because we start doing these problems now and people start misremembering the rules. Whatever I do to one side, I have to do to the other side. So I'm going to multiply this side by 3 minus a. Why did I pick 3 minus a? I picked 3 minus a just to get rid of that term right there. That's it. And now I'm going to bring this guy into the brackets. Okay, so there's two terms. Inside this bracket, there are two terms. There's this term and this term. This term has terms inside of it. But I'm not worried about that right now. I'm just multiplying by the outside. So at the end of the day, I'm going to be left with 3 minus a times 4 minus x all over 3 minus a plus 4x times 3 minus a equals, and I'm going to expand this guy, so this will be 6 minus 2a. Okay? And now I can expand this one, and this guy just cancels with the bottom, right? This whole thing cancels with the whole thing on the bottom. Okay, if you expanded this, probably wouldn't help you very much. But that's what it does. It cancels with the bottom there. So now we're left with 4 minus x plus, what's that, 12x minus 4ax equals 6 minus 2a. Alright, so I have one thing here that doesn't have an x in it, so I got to get rid of him. So I'm going to take a minus 4 on this side. So now I'm going to be left with minus 12, and this was going to be 11x minus 4ax equals, this is going to be 2 minus 2a. Okay? And now I can get rid of this x. Now I can do it. Now I have x's on this side, nothing on this side, so I can remove this x. So I'm going to be left with x, 11 minus 4a equals 2 minus 2a. So x is equal to 2 minus 2a all over 11 minus 4a. And there it is. Okay? If you're tempted to start canceling this stuff like this, you just don't. Like, I don't know what rule I've ever shown you that you can pick and choose terms. Okay, you can't do that. Only if these things are exactly the same, you can cancel them out. Just like here, right? I had 3a, I had this thing. Let's expand this thing, because I feel this is a real confusion part for some people, okay? So I just want to show this term in kind of in general terms here. So let's just expand this guy here. So this is going to be 3 minus a, bracket open, 4 minus x all over 3 minus a. So what I really have here is I have 3 minus a, 4 minus x all over 3 minus a. That's what I have. That's what that is, right? Because this thing inside this bracket, if I multiply this thing into the bracket here, I'm multiplying by the top. So I'm just going to be multiplying those two. Now, I could expand this, and this is going to be something that I want to show you. This is essentially that FOIL thing that you guys talk about. If I wanted to expand this, I could, okay? So I'd be left with 3 minus a times 4 minus 3 minus a times x all over 3 minus a, okay? And then I could expand this again, okay? Expand it again. And I would be left with 12 minus 4a minus 3x and this minus has to come in too. Okay, remember this one. This one's a little tricky because this is actually the x should have came out front here, so it's actually negative x coming in here because it's the x is coming in here, but then I have a minus sign. Remember, I can't drop the bracket because I have a minus sign, so the minus sign is coming. So it's negative 3x, and this one's going to be x times a, which is negative ax, and then times the negative, so it's going to be positive. So it's going to be plus ax. Okay, so all over 3a. And what I want to show you here is this is FOIL, right? This is that FOIL thing that you guys, might have learned about in class. This is FOIL, and FOIL stands for first, outer, inner, last. First, outer, there it is, 3 minus negative x. Inner, last. Okay, but really it's just expansion of brackets. So I wanted to show that. Okay, I wanted to show you that. We're not really there yet. But that is FOIL, okay, when you have these two brackets. And, this is a more impressive thing to learn because then, you can expand it. If I had 3 terms inside this bracket and only 2 terms here, which we'll do for the next problem. And anyways, the point of me writing this piece of paper here is to show you that this thing here essentially cancels. It's like having beta times 4 minus x all over beta. Right, so betas cancel. It's if I let beta equal 3 minus a, right? If I let beta equal 3 minus a, then this is clear. Now you're like, oh yeah, this makes sense. That makes complete sense. But this works too because they're in brackets. It works. It's the whole thing. Right? That bracket is exactly the same as that bracket, so that's why that can cancel. Okay, so don't get confused with some people, trying to be like, oh, maybe I can cancel this 2 with this 4 here and make this a 2 and make this a 1, or maybe I can cancel the a's. You can't do that. Okay, you just can't do that. So don't get tempted to do that. Now let's do something a little more expansive here. Let's try this guy, and instead of using your FOIL rules, maybe you can use what we just learned. Okay, so I'll make it a minus x plus 2 times beta plus c, okay, equals 4x. Okay, so when we expand this, all we're really doing is just taking this thing and expanding it in here. Okay, you don't have to worry about no rules with this FOIL thing. I don't like FOIL, so we'll just expand that in there. So you're going to get beta times a minus x plus 2 plus c times a minus x plus 2. Bracket close equals 4x. And then we can expand this again. So that's all I did. See, if b times this thing plus c times this thing. There it is. And now I expand this again. So obviously FOIL is a little faster. It doesn't take 2 lines. But this is a much better way of expanding things because you can do any size now. It doesn't matter. It doesn't have to be a 2 by 2 with FOIL. This is a much more expansive way. Okay, so there it is. There's the expansion of a 3 times a 2, essentially, right? A 3 terms times a 2 terms. Okay, so now what we can do here is we can now move all the x's on one side. So we have minus beta, minus 2 beta, and minus c a, and that's it. Oh no, minus 2c. Same thing on the other side. I'm not going to even write it because I think we're getting good enough now that we don't have to write it. I don't even write these things up top. I just kind of move it myself. So I don't like to start off an equation with a negative either. So we're going to start off with a positive. Nope, none of them positive. So I have to start off with negative. Negative beta x. There it is. Minus cx, and then we have a minus 4x equals. On this side, what we're going to have here, I would like to start off with a positive. I don't. They're all negative. That's crazy. Okay, so minus beta a. This guy goes over, so minus 2 beta, and then minus c a, and then minus 2c. Okay, and because I hate negatives so much, I'm just going to multiply everything by minus 1. Okay, I can do that, no problem, as long as I do it to the other side. Okay, so then I'm going to have all positives, which would be awesome, and then I'm going to extract the x's too. Okay, I'm going to do that on one step here. So x equals beta plus c plus 4 equals beta beta a plus 2 beta plus ca plus 2c. Okay, negative, 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 positive, 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 and negative, 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 positive, positive, positive. So here we go. So we're going to now divide by this guy right here. Beta plus c plus 4. Beta plus c plus 4. Now remember, we just talked about this last slide here. It's brackets, right? So I can cut out that whole thing. It's the whole thing. Now I can't cancel anything out here, so it's just going to be x equals beta a plus 2 beta plus c a plus 2c beta plus c plus 4. Okay, a lot of people might be asking now, being like, well, maybe I can simplify this top one. I can do the reverse bracket operator for some of these terms here. Like I could take out the beta, or I could take out the c, or something like that. Yeah, you can do that. Actually, I think this thing would turn out nicely into, I think this almost can factor nicely. But, you know, this thing is almost, I don't like teaching that, okay? Because it is a guess and check operation. I bet you this one breaks down. Because it's a guess and check. There is actually no analytical solution for factoring this out real nice, okay? So let me just see here, plus CA plus 2C. So I don't usually teach it, so this is just beyond the course right now. But I think I can take out a B, A plus 2, and then I can plus C, and I'm left with an A plus 2, right? See, look at that. So now that means I can take out again. Okay, so I took out a C there, and I'm left with I took out a B there, and I'm left with that. And now I can take out this thing, right? I'm going to take out this thing out of that. So then I'll be left with A plus 2, bracket open, beta plus C. So that actually is nice, okay? So you could have converted that into that. I generally don't take out things of the brackets, but you could have, okay? So you could have done this. Could have done this. Okay, but you don't have to. Okay, let's move on. Okay, let's get into some harder problems type. Let's get to some harder type problems here now. I want brackets inside brackets now. Okay, so we're gonna go bracket open. Here we go. Now we're gonna go. I'm gonna bury x in here. Okay, plus I'll make a sine of theta. Bracket close all over 4 minus b plus 3, and bracket close that thing, and we'll make that equal to, I don't know, gamma minus 2. Okay. Okay, so I bury x in there. Okay, so how are you going to get x out of there? And this is that whole rule. So this is now where we're starting to really expand these things. And I don't want you to get intimidated by these types of problems. It's just slowly but surely. So I have a couple options here. I could either multiply the 4 in first, or I could multiply everything by this 4 minus beta, because I have 4 minus b, because I got to get rid of that fraction. I hate that. And same with this thing here too. So a lot of different options. It doesn't really matter which way you go, right? Like, what do you do? So you just kind of, you just have to make sure you do the proper thing. So I'm gonna multiply this 4 in first, okay? So what inside these square brackets, the 4 only sees 2 terms. So don't worry about the inside of those terms right now. So I'm gonna multiply here. So I'm gonna be left with 8 bracket open, x plus sine theta bracket close all over 4 minus b plus 12. Equals gamma minus 2. Okay, I dropped the square brackets, and I've been doing that a lot, but you can notice I only drop the square brackets when there's a plus sign, nothing in front, and nothing onto the power. Okay, that's the only time I can multiply. Now, I'm going to get rid of this fraction, because the fraction kills me. And I'm also going to expand this same time. Okay, ready to do that? So let's do that. So I'm going to do, it's going to be an 8x plus 8 sine theta plus 12, bracket open, 4 minus b equals gamma minus 2 bracket over b. Oops, no, that's going to be a 4 minus b. 4 minus b. Okay, so that's with me outwriting the with me not writing the little helpful hints on the side here. Okay, but hopefully you still see what we're doing here, right? So what I did here, now I'm going to write the helpful hints. So I'm going to take this thing, and yes, that's what we did. We multiplied this by 4 minus b, and this side by 4 minus b. Okay, and this guy came in 2 times, canceled there, so I'm left with that thing. Oh, and I also multiplied this thing inside here, 8 and 8 there. Okay, So these guys I'm probably going to keep together. I could expand it, but I don't really have to. Okay? Remember, what was that rule? Expand so you access terms with x. Okay? You don't have to access terms without x. Don't worry about it. It's just a big term. That's like what we were doing initially in our first type of problems. Remember these types of problems? Right here. So I had like this crazy thing here. Well, just take it and subtract it over here. I don't have to worry about it because there's no x in there. Or I just subtracted this side, right? So I just subtracted this thing. You don't have to expand that. That's a crazy expansion. That's a binomial theorem expansion. Same with that. No, that one's not. That one's just a crazy expansion. But don't worry about that. You don't have to expand it. Okay? So same thing here. I don't have to expand these because there's no x's in them. So I'm just going to leave them together. They're more compact that way. Okay? But I'm going to move everything over. So I'm going to be left with 8x equals, I'm going to have a bracket open, gamma minus 2, bracket open, 4 minus b, minus 12, 4 minus b, bracket closed, minus 8 sine theta. And now we see something here too. We're going to divide by 8, and you could expand this. You could expand it either way. It's the same thing. But I do see something here that I can take out this 4 minus b. So I'm going to be left with 8x equals. I don't usually do this, so don't feel complied that you have to do this. But I'm going to get 4 minus b minus 12 bracket closed minus 8 sine theta, and then I'm going to divide by x, and it's going to look real nice now because now I got a gamma minus 2. 4 minus 12 with a 4 minus 12 is going to be negative 8, so I'm going to get minus b minus 8 bracket closed all over, minus 8 sine theta all over 8. Okay, so there's that one. Now you could have expanded this and you could have had a whole bunch of terms up there, and I'm fine with that too. Okay, no big deal. Okay, let's do one more. Now they're becoming harder and harder here. Okay, so this is the type of these are the type of quiz problems I'm probably going to give you. Okay, so we will be expecting those. Like I said at the beginning of the course or the video, this is our last videos. Hope you enjoyed everything. I'm going to have a quiz coming up. There was an error in one of the quizzes, so I had to redo that quiz. So no big deal and redoing that one. Plus there'll be a vector quiz, and there'll be a solve for x quiz, and then I'm going to have a test, not this week, but next week. Okay, but all these details will be in an outline. Will be outlined in an email, and it'll just be an online test. And then you'll be switching over to Marie Henry. She'll be the new teacher, and she's going to change the schedule. But again, she's just on YouTube as well, so no big deal. Okay, what are we going to do here? Brackets inside brackets. Let's do our brackets inside brackets. Let's do x minus 4, bracket closed, bracket open. Let's go 1/3. I haven't done this one yet. Gamma minus alpha, bracket closed, plus 7, bracket closed, plus 3x minus 2. Okay? Okay, what are we going to do here? What are we going to do? I gotta get that x out. I gotta get that x out. Oh, I didn't even make this equal anything. Hold on. There. Okay, I gotta get this x out. That x is good, but I gotta get this x out. So I'm gonna expand this guy in here. I gotta expand him in. Okay, so we're gonna expand this guy in 2 times. So it's gonna be left with 1/3 x minus 4, bracket closed, gamma minus alpha plus 7 x minus 4 plus 3x minus 2 equals 0. So now we're going to expand this guy. Now you could use the FOIL. So we could use the FOIL here. We're going to have to expand this guy, and then we could use the FOIL, or we could do the new method here. So I'm going to multiply this guy into here first. So I'm going to keep the 1/3 out, and then I'll keep x times gamma minus alpha minus 4 gamma minus alpha, bracket closed, plus 7x minus, what's that? That's 28, plus 3x minus 2 equals 0. Okay. Okay, here we go. Let's make sure I did that right here. Yeah. And, yep. Okay. And now it's going to keep the 1/3. Oh, let's get rid of this 1/3. This 1/3 is kind of making me mad now. So I'm going to multiply everything by 3. I'm multiplying everything by 3. So we have to expand this guy. So we're going to be left with gamma x minus alpha. Actually, you know what? I don't need to expand that. That could be a coefficient. But let's expand it. It's okay. X minus 4 gamma minus alpha plus. Okay, I'm not going to expand that one. So I'm going to expand this one. There. And there. And then this one here. Good to go. And we're going to multiply everything by 3. So this becomes 21x. And I got 28 minus 2. So that's actually negative 30. And then multiply 3. So it's negative 90. And then plus 9x equals 0. Oh, and I could add those two together. I didn't do that. Okay, so now let's bring everything else over without an x. So now I'm going to be left with gamma x minus alpha x, and then plus 21 plus 9 is 30x, and then equals, I'm going to bring the 90 over, so it's going to be 90 plus 90, and then also plus 4 gamma minus alpha. All right. Okay, take out the x and divide through. I'm going to do that all in one step. We're good to go. 90 plus 4 gamma minus alpha, bracket over, all over, gamma minus alpha plus 30. Boom. There it is. Let's just check it. So now you have to check it. You know, with math like this, you gotta check it. So that's why it's nice to have multiple lines here, because you can read it. It's like reading a manuscript. Okay, so let's just check it real quick here. Yeah, that's all good to go. And then you multiply that. Good. Bring. What happened here? What the heck? Oh, wow, this was hard. Yeah. Okay, so this one. Okay, so over here, I expanded this one into here. So I should draw little lines here. So this one went to here like that. So then there's that one, and then minus 4. Yeah, there it is. Bracket open with that 1/3 there, and then 7x, and then minus 28, 3x minus 2. Okay, and then I multiply everything by 3. So that applies to everything from here onwards. So 3. Yep. Yeah. Looks about right. You know, that looks pretty good, right? All right. Yeah. Okay, that's going to be it for today. Hope everything's well. Give me a call if there's any issues, or just email, and you will be expecting some quizzes. By the time I see you on Wednesday, you'll have some quizzes up. Okay, talk to you guys later. Bye-bye.